Hello, class. This is Mr. Hart. And in this podcast, we want to start a unit on astronomy. And there are a lot of cool things we can talk about in astronomy, like neutron stars, black holes, stuff like that. But before we get into it too deep, I want to start by thinking about how we got to the point where we know so much about our universe if we haven't been there. How did we discover so many things about places we can't even go to? And so I want to start by looking at the history of astronomy, how we got to this point. Okay. In order to do that, we have to start thinking first about our solar system. Okay. So what is the solar system? What are we considering with our solar system? Well, the solar system just includes anything that is affected by our sun gravitationally. Okay, so the word solar means sun, and so everything that has a gravitational motion that's caused by the sun is part of the solar system. So that contains all the planets. Hopefully you learned those in grade school. Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune. Also, some of the exoplanets and dwarf planets like Pluto now and Eris. Okay, and there's this belt of ice comets that sits on the outside near here. Okay, where Pluto and Eris are nearby. That's what we call the Kuiper Belt. It's considered pretty much the edge of our solar system. Okay, so anything that's in this area is part of our solar system. All the planets, the asteroid belts, the Kuiper Belt, they're influenced mostly by our sun, and so they're part of our solar system. Okay, and so we know a lot about the stuff that's nearby relative to us in astronomy. Okay, but there was a point where we didn't know anything. Okay, nothing. We just knew that we were on Earth, and we didn't even call it Earth back then. We were just on some spot of land, and we could look into the sky and see the stars. So I want you to think about, how do we know this and what led to this? How do we know about the solar system and anything in astronomy? So I want you to take your mind back to an uncivilized era, okay, before there were cities and scientific methods and things like that. What would you think as you looked into the sky and you saw the sun and the stars? Okay, what would ancient people have thought about astronomy? Okay, well, it turns out they had a lot of religious beliefs about astronomy. Okay, and so the ancients used the stars and the sun and thought it was kind of this manifestation of some divine power, and they used it to determine their fates. They had astrology, this idea of looking at the stars to determine destinies and things like that. So it was very much just a kind of belief system for them. They didn't have a whole lot of scientific understanding or theories of what was causing it. They just thought it was these manifestations. But they were pretty good about keeping track of the stars. Okay, so one of the things we attribute to even the earliest of civilizations is its ability to track the stars and see how they were behaving over time. They used this to predict seasons and times of year and things like this. So it wasn't until a little bit later that the ancient Greeks came along. And they were really the first ones to start getting some good hard data about the stars, how they're moving, kind of this idea of, you could track position over time and predict things. And they also came up, they're accredited mostly with the idea of the Earth-centered solar system, or the idea that the Earth was round and it was the center of the universe. Okay, so the Greeks were the first ones to say, okay, the Earth's at the center. We can show all these planets and the sun are moving around the Earth. So they were really big into astronomy. In fact, the word planet means wanderer, and that's attributed to the Greeks. They called the planets these wandering stars because they didn't know why they were moving the way they were. But anyways, they give us a lot of our understanding of the solar system initially. This idea that the Earth was round was, huge. But because they had a strong belief, again, kind of in these religious ideas, they had to put the Earth at the center. And they always thought that the Earth would be at the center because that's where humans existed. And so if that's where people existed, it made sense that that would be the center, not the sun, because the sun wasn't anything special. And so they thought the Earth had to be the center of the universe, or at least what the universe was to them. Okay. Another thing we attribute to the Greeks is they also discovered 5 of the planets. Okay. Jupiter, Mars, Mercury, Venus, and Saturn. They were able to see just with the naked eye. Now, it isn't until much later, even until the Romans come around, that the Greeks make another discovery. Okay. And this is attributed to a man named Ptolemy. Okay, and he lived very late in the 100 or 170 AD range. Okay, is his believed birth and death date. And this is when the Romans would have been in power, so the Greeks weren't a huge empire at this point. But he was a Greek mathematician that showed that you could predict the planet movements by using what's called epicenters. Okay? And so he showed that if you allowed the planets to move in kind of a circular motion in their own orbits, they can make these strange loops as they go. And so he believed that all the planets were moving around their own little centers, and they had epicycles, and so they rotate as they rotate around the Earth. Okay, again, it's kind of this crazy mathematical model, but it worked. It predicted the data really well. And again, because the Greeks were so strongly convinced that the Earth had to be the center, they held very strongly to this idea. And so even though the math and the model was crazy, they believed it because it said, oh, look, it's predicting what's happening. The Earth must be the center, and this is how, the skies work. Okay? So we're talking 1,000 years, okay, thousands and hundreds of years that people believed this and held to the Ptolemaic model because they held so strongly to that belief that the Earth was at the center of the universe. Okay, so people just accept that for a long time. Okay, the Ptolemaic model is just the model that predicts the universe. Okay, and it's not until much later that someone questions this. Okay, and you may have heard of his name. Okay, it's a man by the name of Nicholas Copernicus. And he was a Polish monk that basically just did astronomy in his spare time. It was mostly just a hobby. But as he looked at the Ptolemaic model and he saw how crazy it was mathematically, he realized that it couldn't be, the true way that things were working. And again, this came from his religious belief. He believed that God was, a God of order, and that these strange epicycles didn't make any sense, and that, if it was supposed to be this divine thing, that we'd have pure circles in orbits. Okay? And so the way that Copernicus is able to justify this is he says that the sun is actually the center of the universe. Okay? And they may have had a notion of a solar system by then, I'm not quite sure. But the point is, he said, if, this is divine, then it must be in perfect circles, because God is perfect, and he would only have perfect circles for his model, or his universe. Okay? And so the Copernicus model had perfect circles going around the sun. Now, interestingly enough, Copernicus actually never says this. Okay? Again, he was a Polish monk, and to go to the clergy and say that you believed that, the Earth wasn't the center of the universe would pretty much be considered heresy. And so he was so afraid of the clergymen that he worked with that he didn't want to propose this idea. And so he actually waits until he's on his deathbed, and he has these whole sum of papers that he gives to someone and says, go publish these. Go get this out. I think the sun is the center of the universe. And then that idea came out. So Copernicus was dead by the time he actually proposed this. Okay, so kind of an interesting fact about him. So anyways, he proposes this. He's not around for it, but it gets kind of denied by the mathematicians because it doesn't accurately predict the movement of the planets. Now that may seem strange because we know that the sun is the center of the solar system. But the key was the perfect circles part. Because Copernicus held so strongly that it had to be perfect circles, it's why it didn't work mathematically. Okay? So, a couple years go by. Two very important astronomers come along. A man by the name of Tycho Brahe, a Danish astronomer, a very rich and famous Danishman, by the way, and Johannes Kepler, who was a German astronomer that was kind of his apprentice, okay, or at least worked alongside him. Tycho Brahe became very famous because he used a whole lot of scientific instruments to gather a lot of data about the stars and planets and things like that. And so he was a very well-known astronomer because he had lots of papers and a lot of data. Johannes Kepler worked beneath him, or kind of alongside him, and he actually uses Tycho Brahe's data to predict or make his own model of the universe. Okay? Now, if you want an interesting backstory, some people believe that Johannes Kepler actually poisoned Tycho Brahe to get his data. But if you want to look that up, YouTube Tycho Brahe, there's an interesting cartoon about what is believed about the connection between these two. So anyways, Kepler takes Tycho Brahe's data and he makes this own model that is also a sun-centered model. But the difference is Johannes Kepler makes ellipses in the orbits. Okay? So this is our current model today, and what Johannes Kepler proposed in what we call the heliocentric model. Okay, so heliocentric meaning sun-centered, and this model shows that the planets don't move in the perfect circles; they move in ellipses. Okay, And this was just by analyzing all of Tycho Brahe's data, and also by coming up with some certain laws that describe how these things should move. So if you remember back to Unit 4, when we talked about gravity, we talked about some of Kepler's laws. How, the speed that a planet moves by is dependent on how much of an arc it covers and things like that. So he's able to describe these motions very well with these laws he had made. Now, keep in mind, at that point, Isaac Newton hadn't been born yet, and we hadn't even thought about physics yet. Physics isn't even really a science at this point, but Kepler was able to analyze the data and make these predictions and laws just based on the data. So it's quite incredible what he was able to do. Okay. Now, it predicts the data really well because it's correct. We know that now. But it still wasn't held on to very strongly by the scientific community, I guess you could say, because Ptolemy's model also predicted the movements. So who was correct was basically the idea. Okay. It's not until a man comes along by the name of Galileo, which you've probably heard of, okay? And he uses this new device that's kind of around called the telescope, okay, that had just been invented, to verify some of Kepler's ideas. One of the things he does is he actually monitors the phases of Venus. Now, you may know the moon has phases, but planets also can have phases relative to us. And one of the ways he proves Kepler's ideas is by showing that the phases of Venus have to line up with the heliocentric model, not the Ptolemaic model. Okay, but kind of like Copernicus, Galileo got in big trouble because the church didn't like this idea of the sun-centered universe. Okay, the Catholic Church actually put him under house arrest for heresy for publishing his findings that the sun had to be the center of the universe, not the earth. So now Kepler's model is proven, the heliocentric model which you use today. But the question is, why is this the case? Up until this point, everything is just looking at the data and trying to explain why it's going the way it is. But now we want a physics understanding of why does this have to be? And of course, the man to come along and prove why that has to be true is Isaac Newton. Okay, so Isaac Newton, the physicist, comes along and comes up with this theory of gravity, okay, and explains that the gravity that pulls things to the Earth is the same gravity that holds the moon in its orbit around the Earth and the Earth in its orbit around the sun. And he's able to show that this gravitational force is responsible for these ellipse-like orbits around the sun. Okay, and obviously there are a lot of other cool things that Isaac Newton's able to prove with gravity, like why the tides are caused by the moon. As it goes across the ocean or orbits near the ocean, the tides are basically just being pulled by the moon's gravitational pull. Okay, and that brings us to basically a pretty concrete understanding of why the solar system is the way it is. Okay, now obviously a lot of stuff has happened since then, but now we have a pretty decent model of the solar system and why it looks the way it does. Okay, so a couple of things to remember, these very important people. Okay, so just understand that the Greeks proposed the geocentric model, the idea that the Earth is round, which is cool, but also the idea that it was at the center of the universe, which was not true. Okay, and they discovered 5 of the planets. Okay, Copernicus, Polish monk, proposed the heliocentric model, or just the idea that the sun was at the center of the universe, not the Earth. Tycho Brahe made just some amazing astronomical measurements for his time. Okay, Kepler modified Copernicus' original version of the model to include elliptical orbits, which is correct. Galileo used telescopes to determine certain features and prove, using things like the phases of Venus, that the heliocentric model was correct. And then Isaac Newton was the one that determined that gravity was the force that was responsible for all this and why this had to be. Okay, so that's the history of how we know about our solar system. Okay, next we'll start to learn a little bit more about what we've learned since then. Okay, our next lesson will be on stars and how we know how they're made and that type of thing. Okay, we'll look a little bit more into telescopes. Okay, there's refracting telescopes that use lenses, and there's reflecting telescopes that use mirrors to, determine, or see things that are very far away. But we'll get on to that later. For now, go ahead and do the homework on the history of our solar system and astronomy. Hopefully that all made sense. Let me know if you have any questions, and thank you for watching.